Okay guys, welcome to the fourth tutorial about Genome2D. It's me, Peter again. So before I start, I want to mention something I forgot in the last tutorial, and that's if you are interested in extending or working with the native Genome2D components, you can find the full source codes on the GitHub as well. These are the examples I showed you yesterday, and inside the source there is a source code for the native genome components, transform, component camera, and all the renderables. So if you want to extend sprite and play around with it or movie clip or anything, you can. Okay, today we are going to focus, and that's literally because we are going to be talking about cameras. In Genome2D there is a default camera, so you don't need to handle it by yourself if you don't want to. In previous versions, you always need to specify a camera yourself, otherwise it wouldn't render anything. But now there is this default camera that's created inside by Genome itself that always takes the whole stage, and it's in the middle of the stage. If we want to, let's say, move something, the view itself, for example, we have, let's start from the previous example. We have 100 crates. Okay, as you can see, these are the previous example. I changed it a little. I added a red, the color transform to the selected node. I removed the blue channel, so it's yellow now. Okay, so we have a scene like this, and now if we want to pan over it, like move the whole view to the right or to the left, the common approach in native display list would be to have a parent for all these, a single parent for all these crates, and then move the parent. That's cool and it would work, but that's how the other frameworks do it. But it's kind of taxing. It's because if we invalidate the transform for the parent, it would need to invalidate all the child transforms. So let's say this crate here has x, let's say 30 and y 10, and it would be inside this huge container. And now if we move the container, let's say to here, it's like 40 and 200. During the update and the render, this crate would no longer be rendered to the 40 and 10 on the back buffer, but it would need to invalidate all its parent transforms. So it would need to say that okay, we are not on the 4010, but we are at 40 440 and 210. Okay, and this invalidation is taking place a lot of time because there are many crates and it's all done on CPU and it's slow. So Genome2D has GPU based cameras, so if you move the camera inside the Genome2D, it doesn't invalidate anything, it just invalidates in itself. So, and it's through the whole pipeline down to the shaders, so it's pretty fast and you don't need to let's think about it. Like, okay, now I'm going to move some transform the whole scene with thousands, because if we are working with particles, there can be thousands of children inside the container, and moving the camera would be like stupid to do on the CPU. Okay, as I said, there is a default camera, so we don't see anything. Now we are going to create our own camera. Let's do it here after the texture initializations. So it's a camera. It's a G camera component, and we are going to create a node because as the other components, camera needs to be inside a node. We can attach it to any node, but we are going to create a new node with the camera component. And now we are going to add it to the root itself. So get instance root add child camera node. What this does is automatically destroys or disables the default camera, which is set up by Genome, because it now expects that if you created at least one camera, you know what you are doing. So it would mess things up if he rendered his default camera and you rendered yours. So now if you created at least one camera, you need to set up everything. Now if we run this code, as you can see, the scene didn't change, but the rendering of the scene did. Why? Because the default camera is always rendered like in the native list, and it's looking at the scene from the center of the stage. Let's look at it again. If we remove this camera, we don't need to remove this line, but just this line, because if we remove this line, there is no camera on the render graph, so Genome will use its own default one. Now this is a 0 0, and this is I don't know what's the default size, 480 I think, and 320, and the camera is looking at the scene from this point, if you take it as in real life scenario, and this is the stage, half the stage width and half the stage height. But it will always look, the default camera will always look at the scene from this to simulate the native display list. Now if we're going to add the our custom camera, it looks, because we didn't set the position, it looks at the 0 0. So we are looking at the scene from the 0 0 as the center, and this is the half the stage width and minus half the stage width and height. So don't be shocked that you are not seeing the scene from the center because you didn't change the position. Now we are going to fix this and set it to stage width and stage height. Okay, so we are basically emulating the default camera now, but we can now work with it and play with it around a little. Since the default camera, it can be accessed if you really wanted to, but it's not advised. You shouldn't move or change the parameters of the default camera. But now, since we have custom camera, we can do pretty much anything with it. Now we are going to define it as a class property, so we can access it from events or signal callbacks. As you can see, my syntax is a little bit confusing. It's a common variation of a Hungarian syntax I used in C for many years. This means that it's a protected variable, and this means that it's a custom. It's not a native language class. Like if we had a number, it would be n. But since this is a custom, our own class, it's a Genome class, but it's our own class, I always use a C, and this is the name of the variable or the property. You don't need to write stuff like that. It was way before the UIs for coding had all these kind of hints and stuff, so it was for the code readability. I still use it because I immediately know what's going on once I look at the code. Okay, so let's say we now want to move the camera around. We are going to add a stage events listeners for keyboard, since we already hooked our mouse and we don't want to move the camera and move the crates at the same time. So we want the keyboard event Pretty simple stuff. We are going to move it on, let's say, arrow, some kind of arrow, like left. So on pushing the key down to the left, we are going to set the camera node. We are now just using the transformations of the node where the camera is. There is no camera specific translations because it's always on the node, so the camera will inherit use the translations on the transformations of the node itself. So we are going to move it by 10 pixels to the left. As you can see, the camera is moving left. Now move it right. Pretty simple. And this does not invalidate any of the children. So as you can see now, this code we had previously doesn't work correctly. Why? Because we use the coordinates, standard coordinates of the stage, so it no longer because now, for example, in camera we are looking at the native stage of 480 instead of 240. So, but the stage we click always takes the stage coordinates, not the camera transformed coordinates. To fix this, we can do it if you want to. So I'm going to do it, and it's easy. When we do this stage X and stage Y, we need to add the camera translation. In this case, we don't know about the camera here. Only the render method knows about the camera, because this is always the camera that's currently calling this render, because there could be multiple cameras calling render. But we can get it from the Genome2D core, like this. G camera is a node core and get camera. This is there are two properties. One is for knowing the camera index. So if we have a camera instance and want to know its index, we can. And this is getting the camera at that specific index. Since cameras are added to the internal array just as they are added to the render graph. So since we have only one camera, there will be only one at index 0, but if we had two, the index 0 would be the first camera we created and added to the render graph. So now we have our camera, so we can basically add the transformations of the camera minus the stage width, because it's a kind of complicated, but 0, 0 is, you'll see. Camera node transform width plus camera node transform Y. Now if we run this, it will not work correctly, because 0, 0 and in default coordinates is here, but since we are looking from the center to look on the left top right, and to view the scene just as a natural camera, we need to subtract the center. I hope this is not too confusing. Oh, node core stage width core stage height, because in the stage coordinates this is the 0, 0, but in camera coordinates the 0, 0 is the center of the stage. That's why we need to move the camera to the stage coordinate system. As you can see now this works, and it will work if we move the camera around. Great, so now we are going to do something different with the camera. There are multiple things that's not usable on the default camera but can be used, especially if we have multiple cameras. Let's look at the properties. What we can change is, for example, the background color. In many cases you will have some kind of background graphics already on the stage, so the background itself doesn't matter. But this is the background, this is the color of the back buffer fill for that particular camera. So let's try background color of white to a white background color. Oh, this is just the readable property. We need to set it like this. Okay, we'll have red. This doesn't work because by default the big background is totally transparent, so we need to set its alpha to 1. Okay, now we have the background color for this viewport or camera set to red. Now let's look at another parameters. What we can do here is change the viewport size. Or let's look at the zoom first. Zoom is funny. This will zoom into the scene. Again, it will mess our work with the click coordinate systems, which is understandable because we don't take the zoom factor into account. It's a simple fix, but we are not going to fix that here. And now we can change the viewport. Those are these four properties. It's the size of the actual rectangle that where the camera renders. For example, we had if you want 2 cameras, we will have one on the half side of the stage and another one on the right side of the stage. So let's say this camera is our left camera. First we need and the only thing we need here to change here is the normalized view width. Normalized because it's in the 0 to 1 coordinate system, because we don't really want to have one like viewport outside of the actual stage. It doesn't make sense, and it's always better to normalize this to the stage size, stage 3D size, or the back buffer size itself. So we want just the half of the back buffer. Our view width would be 1/2 of the screen. Let's try it out. As you can see, we only, again, this will not work because we moved everything. It kind of messes up my tutorial. Doesn't matter because you already know what's going on there and how to fix it. I'm just not going to do that. So now this half is empty, there is nothing rendering there, so we are going to add the second camera to showcase this and render something there. So let's have a camera 2. Simple as that. We can even copy paste this. The problem with the mouse offsets that we are running into would be the same if you went the native approach and had a container moving. In that case, you would need to take into account the container transformations instead of the camera transformations. So it doesn't matter and doesn't make your life easier. There are always these transformations that need to be taken into account. So we have this second camera. If we run this now, we only see this. Why? Because both of the cameras are rendering half the screen at the same and the same stuff basically. So, and this is pretty dangerous because now we are rendering this twice and you only see it once. It's rendered like this, and then there is the second camera rendering the same exact thing on top of it. So watch out for that, because many people, especially in the early days when the camera was mandatory and they had two cameras, run into this. Sometimes you don't even know, especially if you are going to use groups and masks, which we are going to talk about later. So always check. You can check this by enabling the stats and show the extended stats. What this does is show you that there are actually two custom cameras and both of them are rendering 103 nodes. Why 103 if there are only 100 crates? Because those are the nodes. They may not even render, but they are there. For example, this node, camera 2 node, and the root itself. So that's 3 nodes and 100 of the crate nodes. So this is a pretty big giveaway that something's wrong, because there are like 2 cameras rendering this 103 things and we don't see the second camera. So let's move the second camera so we'll see it. We want to just have the half a screen, that's correct, but we need to offset the half a screen to the right. And this is done again using the normalized view X. So this means that it will start on half the back buffer. So split screen. As you can see, both of the cameras are rendering the same thing. We can have even more cameras, like 4 or even 100 if we really wanted to. I don't know why would anyone do that. We can enable and disable cameras on the fly if you want to change between 2 cameras. You can do pretty much anything with the camera that you can do with the node. So you can tween it, you can rotate it. So let's rotate this camera just for fun by half a pi. As you can see, it works. Again, the clicks are messed, but that's because we are not going to delve into the transformation fix. I currently don't support some kind of world to camera coordinates or camera to world coordinates. They are in the to-do list, and I don't think many people even requested them, but there were some. So it's pretty low on the to-do list. But if you want to use it, just let me know. I can bump up the stuff in the to-do list to have it done sooner. And it would be very useful in this case, because we could easily just capture the mouse on the stage and then use some kind of camera method to automatically translate it to the camera space and move the crates accordingly. Now, as you know already, you can also overlay cameras. It's pretty hard to showcase. In the previous state where this camera wasn't on the on the second half of the back buffer. They were overlaying already, so it was rendered the first camera, then the second one. And since there is no background at the moment, since I removed the red background and the alpha, as I said, is by default 0, it's transparent. So the camera will render on top of each other, and it can be used for various stuff. Let's look at this. Now we can see it because one of the cameras is translated or rotated, to be more precise. So we can see both of the cameras at the rendering the stuff on at the same place, but different stuff. So we can see both of them. This is very useful for overlaying, for example, UI on top of game in Geometry Arena, my first game on Genome2D. I used this. There was two cameras in that game. One was used to render the game itself, and the second one was used to render the UI. You may ask how I would do that, since both of the cameras would again render everything. This is not the case, because we can specify what the camera renders. And to do this, we will use the camera mask and the camera group properties. The camera group property is property of the node, and camera mask is the property of the camera itself. Let's create ourselves a container for the crates, because we don't want to work on the root. I advise against working root itself. So we are going to create a simple container, which would be just a node. And add it to the root. We can leave the cameras on the root or move it to the container, it doesn't matter. And now we are going to create these or add these crates to the container instead of the root. What will change? Nothing will change now, but we can now showcase the camera group and masking. So let's say we want to set the container camera group to something specific. By default, the camera group is 0. 0 means that every camera will render it. Doesn't matter what's the camera mask or any other settings. The nodes with camera group 0 will always be rendered by every camera. So let's set it to 1 and look at it. Nothing changed. Why? Because by default the camera mask is FFFFF, so it will render all the bits. The camera group and camera mask work like this. Once the render method is called on a node, it will check if the camera mask and the camera group is 0 or not. If it's 0, it means that none of the bits overlap, so it shouldn't be rendered. If it's not 0, some of the bits overlap, so it should be rendered. So now this camera group is 1 and the mask is some arbitrary large number, as I said, so all of the bits are 1, so it will overlap, so both of the cameras will render it. Now if we change this camera, it's a pretty common usage, these bit masks. I use them a lot in various engines throughout the years. I'm sure you are familiar with it. Even NAPI uses it for collision mask and stuff like that. So now we want to change the mask of the camera to 2. So these two will not overlap, because this is the different bit than this. So let's run it. As you can see, our camera with mask 2 doesn't render anything because the container has the group 1 and the mask is 2, so it doesn't overlap. It doesn't matter that the sprite node itself or all of the crate nodes have group 0 and should be rendered, but in the hierarchy it skips the rendering of the children once it runs into the node with group that shouldn't be rendered. In the previous or really some in early versions of the genome, this wasn't the case. It only rendered the or didn't render the nodes that didn't go through the mask check, but it went through the children's and checked for the mask again and again. But this was like no one knew how to use it, and you needed to arbitrarily set all the children to a correct group so it worked. So it didn't make sense to have it like that. So if you want like two different things to render, one on one camera and to render the other on another camera, we just create two containers with the correct groups, and voila, it works. So now if we change this to 3, just to showcase the masking, it will work because 3 has the bit 1. So again, both of the cameras render the container. Now what we can do for fun is, let's say we are going to set the camera group on the crate itself, not on the container, and set the camera to mask to 1. So or camera 1 will have mask 1 and camera 2 will have mask 2. And now here we are going to set the camera node, the camera group for the nodes. By default this will be 1. So all of the nodes will be rendered in camera 1 because their group is 1, and nothing will be rendered in camera 2. Now here we can do this, that selected crate camera group 1 back to 1, because this is the unselection of a crate, and the selection of the crate we are going to set it to camera group 2. As you can see, once the node is selected, it will be rendered only on the second camera and not in the first one. And if we select another node, this will go back to the first camera, and the new node will be rendered on the second camera. We can also do set the first camera to the group 3, to mask 3. This will render both, even the camera group 1 and camera group 2, so the selected node will be rendered on the first camera at all time. But since we didn't change the second camera, it will only render the selected node. So let's look at it. This can be used for very many use cases. For example, we can have the same level and two different players inside the level that go around, but the left screen is rendering only the player 1 and the right screen is rendering the player 2, and both of them are rendering the level. Keep in mind though that if you used, for example, some kind of physics and the player had a collision, they both exist in the world. The camera is just the rendering. So if you had the collision of the players set so they collide, they would collide in both views. This is just the view to the world. It doesn't mean that the player doesn't exist in this world. And of course it can be used to, as I said in the geometry arena case, to render UI. So I had a UI container and a game container, where the UI container had the group 1 and game container group 2, and it would render with two different cameras, where one would render the first camera, the game camera would render the game itself, and the second camera would render the UI. Since it was the second camera and its render was called the second, it would always render on top. And as you can see here in our stats, we can see that the camera 1 or or 0, that's because this is the 0 index, renders everything. These are the 104 nodes, and the camera 2 only renders this node, but of course it renders all the other nodes that are there that don't have groups, so they are not masked, like the camera 1 node, camera 2 node, and root itself. Okay, let me clean the house here. And this is probably going to be the end of our camera tutorials. If anyone is interested more about the cameras and what we can do with them, just let me know. There is pretty much anything you can do with cameras. You can even, I didn't show it here, you can even move the view. If you twin this, you can easily have a moving viewport. Like for example, you had this the single camera that renders from the whole scene, renders here, and the second one that renders just this narrow view. You can twin some kind of comic-like fashion. You have the viewport twinning and rendering over here. It can get pretty dynamic and quite nice. And as you can see, if we move the first camera, it doesn't move the second, because this moves the camera. So we can have this camera, now both of them are rendering the same coordinate, but we can have this rendering at the 1000th or entirely different thing in the world than this one. Doesn't matter. So thank you for listening, and any feedback is welcome as usual. I don't know what I'm going to talk about next yet, so let me know, or I'll pick it myself by random probably. See ya guys!